Okay, new stuff. It's about the matrix. Not the one from the movie, but math has matrices too. Matrices problems kind of look like this problem right here. And you'll know how to do that by a few days from now. To start with, though, we just need you to learn a few things, some terminology, and we're going to learn about how to graph them. You can graph these matrices too, and then transform them, like move them around. Adding and subtracting is really easy, and then we're going to teach you scalar multiplying, which is really easy. There's a whole bunch of easy things today. Tomorrow is one hard thing called multiplying matrices, just for the future. All right. And I found this one interesting. Jupiter is the largest planet in the solar system. That I already knew, but it's twice as big as all the other planets combined. That was kind of cool. So it's a big honking planet. All right. By the way, what does that mean about the gravity on Jupiter? We talked about this before, remember? Yeah. Actually, I think I figured it out as 2.5 times Earth's gravity. So that means if we were walking around up there, it'd be like you were carrying 2.5 of you around on the planet. So it would be very hard for you to even move on the surface of the planet. What would that mean about aliens that came from that planet to our planet? They'd be like super strong because they're used to being able to handle that kind of gravity. So anyway, just hope for no, Martians aren't what you have to worry about. It's the Jupiterians. All right. Anyway, matrices. So this is a matrix. And you just have these numbers arranged inside brackets like this. And each little element of it is called an element. It's also called an entry. Okay, so the 2 right here, that's called an entry, or an entity, or I found this online. There were a lot of different ways that it was described, but the 2 most common are that they're elements of the matrix, or that they are entries in a matrix. Then this is either a row or a column. Do you know which it is? That is a column. How about if I go this way? What's that then? A row. So this one has 2 rows and 2 columns. So this would be called a 2 by 2 matrix. So remember that rows are like rows in a baseball stadium. I'm going to see if this works. It worked on my other computer. So if I want to go look at the Twins Stadium, for instance, you guys know about a row, that if you're walking down and you're going to go into a row, the rows go across. I don't know if you've ever been to a baseball stadium, but if you have, so if you like click here, it tells you what those seats look like from that view. It's kind of cool. Anyway, how many of you guys have been to the new Twin Stadium? It's not even that new anymore, I guess, but not only about half of you. I'm surprised. Okay, so let's go back to what we were doing here. The columns are like columns on a building that go up and down. That's the one that sticks in my head the best, is that columns hold up buildings and rows go the other way. Okay, so columns go up and down, rows must be going across like this then. Okay, so moving on. The size of a matrix then, this one is a 2 row and 3 columns, and by the way, you always say the rows first, then the columns. It's like RC, like the cola, or like remote control. Okay, so it's always rows first. So we would say this is a 2 by 3 matrix. So you always count this way first, and then this way. And that would be, let's see, horizontal first. And you can make up your own funny way to remember that. All right, anyway, this is some typical questions then. How many rows, how many columns? Remember, rows go horizontally. So this would be a what by what? This number 1 here. How many rows? 4. By how many columns? 3. That's a 4 by 3 matrix. Why does it matter that much? Because it actually does, especially when you get to multiplying. How many rows it has, how many columns it has, determines how big your matrix is at the end. Because you multiply by a small matrix by a big matrix, you got to figure out what the new matrix is going to be. Okay, so just trust me, you need to know how to do this. So for the next one, would you please billboard it up to me and say what it is? Don't say it out loud. Say it's like 5 by 7 or whatever you think it is. Yup. Rows have to be first. Yup, 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 yup. Okay, good. So that's do 3 and 4 quick, and I'll tell you in a moment what they are. But for those listening at home, the rows on this one, 4 rows, columns, 2. That was a 4 by 2. How about this next one? You agree it's 2 by, and then it's 4. Yep. Obviously, a 2 by 4 and a 4 by 2 look totally different than each other. And this last one, 3 by 2. Raise your hand if you agreed with me. Okay, good. Any questions? Yes? Yep. It has to be rows then columns, RC. Okay, and then how many rows do I have? 1, 2 rows. And then the columns is the other way. It can be confusing because it's you know, it's easy to mix the two up. If the matrix has the same number of rows as columns, the matrix is said to be a square matrix. Well, that is the easiest, of course. If it's 3 by 3, you can't possibly screw up which is the rows and which is the columns. But you still got to try to remember rows go this way. Because when you're multiplying, you're going to take a row times a column. And if you get your rows and columns mixed up, it'll get all backwards and the answers aren't commutative, so you can't reverse them. So you'll get your answers wrong. All right. So this is a square one, and of course, if you had a 2 by 2 like that, that's a square matrix also. Anything that has the same number of rows and columns is square. That's easy. Okay, where do you actually see these in real life? A seating chart, for example. Anytime you arrange things in a big rectangle. A seating chart, your monthly schedule. You know, if you look at a calendar on your iPad or wherever you keep your calendar, your school's schedule that we load up off the internet, a photo album keeps pictures, which are all little rectangles, in big rectangles. You can make them long and skinny, you can make them short and fat. All right. Notation and formatting. This isn't super important. We're not going to hold you to this very much, but you should know it anyway. If I said that this was matrix A, then this number right here, for instance, would be called little a, because you don't want to use a big A or you're talking about the matrix. And then you got to say 2 numbers. And of course, rows are always first. So I would have said, if I was making this little slide up, I'd have said R, and then that one should have been a C. A little R and a little C. So what R is this in? What row is that thing in? That's in the first row. Remember, rows go this way. So easy to get that goofed up. That's in the first row. And which column is it in? The second. See, this is in the second column. So that's row 1, column 2. So if I say A1, 2, I should put a comma in there, by the way. That says I'm talking about that spot right there. In row 1 and column 2, where they overlap is that spot right there. And so it's the 3. Okay, so this, tell me, that 18 in A, what's its name? Here's matrix A. The 18, there's only one of them, it's right there. What's its name? It's a little a and then 2 numbers. Little a, and then what's row? 1, 2, 3. Row 3, comma, what's its column? Column 1. A3, comma 1. Raise your hand if you knew that. Okay, good. Then figure out this next one. And let's do these 2. Answer those 2 for me, and I'll check them as you turn them my way. Remember, use little b, not big B. Yes, yes, yes. You need a little b. You have big B's. Yes, 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 yes. Yes, okay, good. Almost everybody's getting these right. Yep. Okay, so this one was little b, because otherwise you're talking about the matrix itself. Little b means an element in the matrix. And if we're talking about the -6, it's right here. And so that's in 1, 2, 3, 4th row, comma, second column, 4, comma 2, for example. And the other one was B21, I think, wasn't it? Okay, good. On to the next one. Uses for matrices. We're going to show you how to do this 2 days from now, where you can take an equation like this and you put in, you see how we take the numbers out of the equation? This one doesn't have a number, so I'm putting a 1 in there. 2, 3, -1, and 6. 2, 3, -1, and 6. You see how we're taking the numbers out of the equation and we're popping them in the matrix? Once you do that, you can solve this system of equations super simple. Get how we just have to pull the number out of each of these, put it into there, those spots. And if I do that and I type this into the calculator can do matrices for me and solve that system and tell me, oh, so from the data you gave me, I know that x equals 2, y equals 3, and z equals -5, or whatever it is. It can solve that for you. Pretty complicated system of equations here. And you can use a matrix like this to solve it. I'm not teaching you how to do that yet. Just trying to tell you this is an example of how you could use these matrices. You pull the numbers out of equations and put them into a matrix. From there, you can do things like solve systems of equations. You will learn that on Friday, I think it is. All right, so here's another use for a matrix. You can graph things with a matrix. These are the x's, these are the y's. Doesn't that make sense? If I did it the other way, how on earth would I do it? You know, like if these were going to be the x's and these were going to be the y's, then what the heck are those? You know what I mean? So the x's have to be one way and one row, and the y's have to be the other. So that's the x row, that's the y row. Does that make sense? And then you just graph those points. And once you graph the points and connect them, you'd get a shape. So do you see how you can actually get a shape out of a matrix like this? Old school video games were actually done that way. They'd put this into program the computer to tell it what shape it wanted it to move around on the screen. You'd give it a matrix of numbers. And anyway, I'm pretty confident they don't do it that way anymore, but I do know that's how they used to do it. Adding and subtracting matrices. This is as simple as you would think. This 3 right here, what do you think it goes with?
4.
The 4, and makes a total of 7. And you have a little matrix at the end that you hold your answers in. See what I mean? This 2 goes with this 8, and you make 10 total, and there you go. That's all you got to do. Okay, would you please figure out the answer to this matrix right here? Make a little matrices the same size as the ones we start with, so right there, and solve this matrix problem. A little faster than I am, so hold on a second here. Can I see again? I think you're right, and let me double check that. Oh yeah, definitely right. Nice job. Okay, good. 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 Yep. Can't see yours. Can you zoom it a little bit? I got it. That's good. Something's wrong. Back row. Good. By the way, this is a subtract problem. Maybe that's the problem. Yes. Can't read the numbers. Can you zoom in a little closer? That is correct. Yes. Okay, since pretty much everybody I'm checking is doing it right, I think you're getting this. I don't need to take too long. 1 minus 3, -2. 5 minus 2 is 3. 6 minus 7, -1. And all the bottom ones, like 3 minus 3 makes 0. They're all zeros. There we go. Okay. Now, what about this one? Just a quick note. This third one. Let's answer that one. There is no answer to that one. You can't do that one. I know you could make up a way, but there is no official way to do this. You need your adding and subtracting ones to be the same size. And this is a 2 by 3, and this one is not a 2 by 3. It's a 1 by 3. Now, if they don't match up exactly, you cannot add and subtract them. Make sense? All right. I mean, I know you could make up your own rules if this was, you know, your decision. You could say, well, you just have to subtract, you know, take all of these and subtract this, and then take all of those and subtract the same things. You could make up your own rules, but there is no math rules for doing that. It's just undefined. All right, this is called multiplication by a scale. Do you get how if you scale something up to 3 times as big as it used to be, that's called scalar? Does that make sense? So it's a scalar multiplication. It's just timesing everything by 3. It's as simple as you'd think. 7 times 3, 21. 3 times 2, 6. 3 times 0, 0. 3 times -4, -12. There you go. Just multiply by the number on the outside. And then this, of course, does a combo deal. You first multiply everything because multiplication comes first in the math rules. Please excuse my dear Aunt Sally, right? Once you had them all multiplied out, you just add them. Raise your hand if you think you understand what to do there. Okay, good. Let's not waste the time on doing it then. This one is actually a graphing question. Remember how it has to be like these are x's and these are y. So if I'm going to graph -3, 2, I'm going to put that on my graph, and I'd like you to do that too. -3, 2. Put a dot on there. 1, 3. That's this one I'm doing now. 1, 3. And last, 2, -2. I have a triangle all pre-done ahead of time. There we go. Okay, now can you imagine that I do a translation left 3? Now think about this. In the past, we've always had equations, and so it went counterintuitive to what you would think. This is intuitive, which in turn makes it counterintuitive because it's different than the other ones, which were different than what you'd expect. So you get how confusing that can be. Okay, but bottom line is, in the past, we said left 3 was always like a +3. Do you remember that? Well, now left 3 is actually, well, left 3 is left 3. I go to the left, 1, 2, 3 spots. But I actually have to subtract 3 from all of my numbers. How do I do that? I go like this. -3, 3, 3, 3, 3, and 3. I just moved it to the left 3 is -3. I know we're used to being the opposite of that because, again, you were always doing an equation before. And the stuff was on the opposite side of the equation as each other. But now it's not. So now if I just want to take -3 and move it left 3, I have to actually subtract 3 from -3. That way I will get an answer of -6. And this one, when I take 1 and I subtract 3 from it, it'll be at -2. So look, -6, okay, hold on. Not -2, sorry. I was putting my points together wrong. This 2 and this 3 would make a -1. There we go. -6, -1. Why, what am I doing wrong? I'm going to pause for a second while I figure this video. Okay, I figured out my mistake. One of the kids actually figured out my mistake. It's I was subtracting 3 from both the x and the y, and I really wanted to leave the y's alone, so I'm going to subtract 0 from those. Because I'm only going left 3, I'm not going like up or down. So it's only should have affected my x's. So anyway, bottom line is I subtract 3 from everything, and I'd get, for instance, this and this would turn into this and this. -6, 2. Here's -6, 2 right there. And you see I have moved it to the left 3 spots. Okay, so that's the basics idea on graphing matrices. This has been a fairly quick lesson today, but it's really not super hard stuff. So I think this is the part where we'll just jump into the homework, get you started on that. I am going to have to grade some of those top 20s today that I've asked you to get done, and hopefully you already are done with those. But for right now, let's just get your homework up on the screen. Pause for a second while you do that. All right, so here we go. This is matrices day 1, and here is a set of numbers in a matrix that they want you to graph. And it's going to end up being a triangle because it's going to have 3 points. That one, and that one. So if I think you guys can graph that. That's going to be very easy. Let's talk about the next part. What matrix represents the image of this triangle after a translation left 3. All right, so you've got your first 3 points. Then you move it left 3, and you've got 3 points. Let's say it's like this. All you got to do is write down the vertices, the corners of your matrix. So if this was at like, -7, 2, how do I put that in a matrix? Well, final answer is going to be the same shaped matrix as it was in the first place, with 3 spots this way and 3 spots that way. Okay. And now to put in my first point, if I have a -7, 2, I go -7, 2, like that. So you just figure out where your triangle is, and then you put in your points. Remember, these are points this way. And the top number is the x. All right. And then they're going to ask you to move it to different places, and basically you just keep changing your matrix numbers to represent, okay, right 4 and down 2, that takes all my x numbers. And remember, right 4 used to be -4, now you're adding 4 to do right 4. You can do +4 to all your x numbers. And then down 2, that's a y thing. And down 2 has always been one we could kind of trust, so we do it the normal way. So down 2 means -2, so you actually subtract 2 from all your y's. And this is all your x's, you're going to add 4. And your answers are a matrix that looks just like this. It's just the numbers will change each time. So your answers will look just like this. All right. I'm going to clear the ink and move down to the harder part. Actually, it's not even harder, but the different part that's not graphing. Here you're just adding them. They want you to figure out what y or x would be. Here's x. That must be this plus that. So you write your answers in a matrix just like this is written. So if I figured out that the answer was like 4, 7, 12, that's how I'd write it, like that. Actually, no commas. Matrices do not have commas in them. 4, 7, 12. Makes it that much more important to leave space between them so it doesn't look like 712, for instance. All right, that one's not 4, 7, and 12. I guess I can just do it for you. 3 and 9, 9, 12. And then this one's 12, -12, minus, plus -12, which makes 0. And then it's -8 plus 13, and that's going to be 13 effectively -8, which makes it, I think, 5. Anybody else have that one as 1205? All right, good. Seems like you're agreeing that I didn't screw that one up. All right, and then down here, don't forget this. You multiply these first, and then once you're done with them, then you can add them to get your final answer. All right, that's all the tips I have for you for today.